Good afternoon, and welcome to this installment of the Galen Healthcare Solutions webcast series. Today's topic will focus on the GalenETL platform and its ability to produce consistent results that have led us to the completion of hundreds of successful data migration projects. I'd like to remind everyone that you are muted when you come into this webcast. You can use the Q&A panel on the right side of your screen to submit questions, and we'll try to get to those at the end of the presentation. All unanswered questions will be posted in Q&A form on our blog and wiki. To begin, I'd like to talk a little bit about Galen Healthcare Solutions. We are a healthcare-focused service and solutions company. Our staff is comprised of clinical workflow and operation experts who have an average of 12 years of experience in the field. One of the key factors of our success is our company culture. Our expertise is both wide and deep, and our employees regularly make themselves available to each other in order to ensure the highest quality of services to our clients. For over a decade, Galen has built a solid reputation of providing high-quality, expert-level IT consulting services to health systems, hospitals, and physician practices. We provide world-class professional and technical services to healthcare organizations that interoperate, aggregate, convert, harvest, and optimize clinical patient information within your multi-vendors system portfolio, including PM systems, your EMR, and also HIE. We deliver a suite of fully integrated products that enhance, automate, and simplify the access and use of clinical patient data within those systems to improve cost efficiency and quality outcomes. If you are interested in hearing more about any of these services listed on this slide, there will be contact information at the end of the presentation. Your presenter today is August Borey, a lead technical consultant here at Galen. He has worked in the healthcare IT industry for 6 years and has extensive experience performing data migrations across multiple vendors. He's also the co-developer of our GalenETL platform, making him an excellent resource for today's topic. Now here's August to take a deeper dive into data migrations powered by GalenETL.
Thanks, Julie, and welcome everyone to today's presentation. To start off, I just want to give a quick overview of the topics we'll be covering today. To begin, we'll give an introduction to GalenETL, talk about what it is and its basic components. Then we'll talk about what makes GalenETL unique within the industry and the data migration space. We'll move on to mapping and translations, which are a key part of any data migration. Next will be document transformation, which refers to converting between different types of file formats like PDF, TIFF, etc. We will discuss the different outputs GalenETL can produce, from HL7 messages to continuity of care documents. After that will be vendor-specific custom plugins, which we have created to deal with how data in certain EHRs is stored. Followed by Extractors and Parsers, two interesting features of GalenETL. Then we'll cover how we manage customizations during a data migration project. Next, we'll detail how auditing works within GalenETL, and yes, everything in GalenETL is audited. And we'll examine the validation script generator, which is a very specific component of GalenETL that assists our professional services team with validation. And finally, we'll conclude with a demonstration of some of GalenETL's functionality. So what is GalenETL? GalenETL is an internal tool at Galen that's used to perform all of our data migrations. As you might be familiar with, the ETL stands for extract, transform, and load, and that's really what GalenETL is all about, and why it works so well to provide data migration services. Firstly, GalenETL provides an avenue for extracting data out of a legacy system, and then staging that data in a database. Then, GalenETL allows for custom transformations and translations, which we'll talk about later on. Last but not least, data is able to be loaded to various systems using GalenETL, whether it be via specific outputs like HL7 messages, or loaded directly into a target system. GalenETL is made up of several components. First and foremost, like I just mentioned, there's a database, aptly named GalenETL. This is the middle tier where all the data is stored before any action is taken upon it. We'll get more into the different types of data in the next slide. Then we have the plugins, which are how actions are taken upon the data in the database. Plugins are the way in which GalenETL, to use a technical term, does things. They are the heart and soul of GalenETL, and it couldn't exist without them. To be a little bit more specific, the plugins are the library files that contain the code necessary to take some action on the data. And the reason they're separate and not built into GalenETL itself is to allow for more flexibility when it comes to working with the data. Most of GalenETL's functionality that we'll talk about today occurs as a result of these plugins. We have all different types of plugins that are available for use with GalenETL. A few of them are just listed here. And actually, we'll talk about all of those types of plugins today. The final piece of GalenETL is the job service, and this is what allows the plugins to execute their tasks and interact with the data. For example, let's say the objective is to create a set of HL7 messages, specifically ADT messages. First, the data would be extracted and staged in the GalenETL database. Then, any necessary transformations would be applied, maybe to translate the departments from the legacy system to the values required by the target system. Then a job would be created, utilizing a plugin that generates ADT HL7 messages. The data would be queued up, and once the job service was started, messages would start to be created. This is actually a pretty common task during a typical data conversion. And the other thing that really defines GalenETL for us is that it represents the knowledge of our entire team. Everyone on the data migrations team at Galen, and even those outside the team, have contributed to the success of GalenETL. Now that we've talked a little bit about what GalenETL is, let's dive into what makes it unique. For starters, it uses a standard data model for its database. No matter what type of clinical or demographic data we're working with, it can be handled by GalenETL. Because we're almost always dealing with patient data, the patient is at the center of the model and their information is stored separately, whether it's their allergies, medications, lab results, etc. It's also completely system agnostic, which allows us to perform migrations with a wide variety of VHRs. We leverage our experience with these different clinical systems to be able to get the data out of those systems and into our data model. As a result of the great team at Galen performing data migrations, GalenETL is also constantly growing and evolving. There's always new requirements and challenges that come up, and while that may seem daunting to some, we see it as an opportunity to improve GalenETL and broaden the array of different services that it can provide. GalenETL is scalable. It functions the same whether there are 1,000 records or a million records. Now, obviously, things might take a little bit longer to process with 1 million records, but the processes are the same that GalenETL uses, so that the effort to execute the conversion doesn't increase exponentially depending on the size of the data. Along the same lines, GalenETL provides consistent execution. When the job service runs, it is handling each and every plugin in exactly the same manner. And this just goes back to the system agnostic aspect too, that the output will be the same regardless of where the data comes from. GalenETL provides full auditing capabilities, and we'll touch more on this later in the presentation about how it audits. If a piece of functionality is added to GalenETL for a specific project, there's no need to go through the work to add it again for a future project. The new plugin, if that's what the change was, or maybe it was a change to an existing plugin, that can be used in a future project without requiring the original effort again. Just another reason that GalenETL is constantly improving. And lastly, tasks are processed linearly. We'll see examples of this in future slides, but this allows for increased flexibility when managing a data migration, and ensures that the analyst has more control over what GalenETL is doing. Now, these are just a few highlights of GalenETL that we think set it apart in the industry, but really the entire presentation today is a study on what makes GalenETL unique and how it can assist customers with data migrations. During every data migration, there is at some point the need to map certain values from the source system to their corresponding values in the target system. The example could be like the one that I mentioned earlier with the departments for ADT messages, or it could be with mapping document types for notes and transcriptions that are being converted. With the breadth of possibilities when it comes to mapping and translating data, the need is there for GalenETL to be able to handle these efficiently and without error. So all of the mappings and transformations for our data migrations are handled 100% within GalenETL. The actual values for each mapping are stored within the GalenETL database, and the delivery of these mappings occurs within the job service. This ensures that any time a job is executed, the translations are readily available and can be applied with very little overhead. It also means that any outputs or products of GalenETL are fully formatted. There's no need for additional scrubbing of these outputs to ready the data to be imported into the target system. You'll see what I mean by this in some later slides too. The mapping within GalenETL is completely customizable. We can map based off system-specific codes and naming conventions, which often have no bearing outside of that specific system. For instance, let's say that the code for a document type of progress note is 123 in the source system. We can map that to a progress note document type in the target system that has a code of 456. And obviously these codes have no meaning outside of their respective systems. We can also map using standardized code sets that are available. For many data migration projects, we leverage ICD-9, ICD-10 codes for diagnoses and problems, RX norm codes for medications and medication allergies, CVX codes for immunizations, and there's others as well. So the reality is that if these codes exist in the source system, we can map on them. GalenETL can also help reduce the manual mapping effort involved in a data migration, which for anyone that's gone through a data migration knows can be quite a lot. For example, if the source and target EHRs use a similar or a common lab order and result compendium, we can match up similar codes between the two systems. We can also look for common trends in the data to see if, let's say, one of the set of codes is prefixed with the letter L, but you remove the letter L, and then the two codes from the two systems match up exactly. This can save resources many hours, and it allows them to focus on the outliers in the data mapping rather than all of the ones that may be similar. So document transformation is a significant part of the services that GalenETL provides for data migrations. If you can think of a file type that's out there, chances are we've probably seen it stored in an EHR. And this may be a little bit of a stretch, but we definitely have seen and dealt with many different file types during data migrations. Probably the most common output that we see is PDF, since it can be handled by so many different systems. GalenETL has the capability to convert many different types of files to PDF, including TIFF, RTF, HTML, XML with a style sheet, and then other image types like JPEG and bitmap, and others. The conversion of these is done on a document-by-document basis and results in a single PDF per document. One of the most popular file formats that we extract out of legacy systems is TIFF. Because we've worked with TIFF so often, GalenETL is able to handle the different compression schemes that are out there for TIFFs. Some of them are pretty rare, but we have seen them. TIFFs are notorious for having different properties as well, depending on the system that they're created in. So we have plugins that handle the different permutations that we've seen with those properties. And the beauty of these plugins is that they can be used for any TIFF, no matter what compression or format issues there may be or may not be for a set of TIFFs too. There's no need to identify certain troubled files ahead of time and handle them differently. So this allows for greater efficiency on the project because all of the TIFFs can be handled together. And then we also have a plugin to convert the opposite way that we just talked about. So we can convert from PDF to TIFF if that's necessary for the project. Occasionally, we run across Microsoft Word documents that are stored in an EHR. Since these require a specific program, namely Microsoft Word, to open them, they must be converted to a more common file format when they're being imported into a target system. We've got plugins to convert Word to PDF or RTF, kind of depending on the preference of the customer and the project. If it's a PDF, that PDF can often be imported into a document management system or referenced as a scanned image, while if it's an RTF, that RTF document can be handled a bit more discreetly and it might display among notes or transcriptions in the target system. I mentioned in the last slide we'll call them intricacies we've encountered with TIFF files. Over time, we've expanded the functionality of our TIFF plugins with the ability to alter the image compression. Certain systems require a specific compression scheme, and GalenETL is able to handle it. We've worked with Group 4 compression, which produces black and white images, generally found in faxing. Another common compression is LZW, which is used because of its lossless properties and small file size. Then there are a couple of other ones as well that we've worked with. JPEG and JPEG 2000, which are more uncommon, but we have seen them. We can convert to these different types of compressions from any other type of TIFF or PDF compression, including but not limited to Adobe Deflate, LZW like I just mentioned, and Group 3 compression. Then there are obscure fixes that we've dealt with in the past with TIFF plugins. So the ability to alter the photometric tag in TIFFs was added in order to correct any color inversion issues that we were seeing, which is basically where the blacks and whites are switched in the image. We found that photometric tag is not consistent in the TIFFs that we've worked with. So we added that feature so that we can set the tags consistently across the board for a given set of images. And GalenETL can also convert color images to black and white if that's necessary. And finally, those that are familiar with TIFFs and have worked with them in the past and know that a TIFF document can contain multiple physical TIFF files that are its pages. And then subsequently, each individual TIFF file within that document can be a single page or a multi-page TIFF. In most cases, when we work with these TIFF files, we combine all of the separate pages, whether they're a single document per page or multi-page TIFFs. We combine them all into a single file, and we either keep it as a TIFF file or we convert to PDF depending on the project. We can, however, if it's required, break every single page out into its own file, whether those are TIFF files or PDF files. So all of these things here, you can see there's many different options available when it comes to working with these TIFF file types. We've been talking a lot about how adept GalenETL is at transforming between different types of documents and images. But what we haven't talked about yet is what happens with those files, those images, once they've been transformed. They need to go somewhere, right? In almost all cases, the requirement for the migration is to either export the files to a specific folder on disk or import the images to a target system. When we export the images to disk, there's often a plain text index file that goes along with it. That index file contains the metadata surrounding each document or image, such as the patient info, the clinical date, the document type, and it also contains the file path to the exported file. And this index file can be totally customized as well. The order of the fields in the index file can be customized, as well as what certain fields are in there. And these documents and images can be exported in any of the file formats we talked about earlier: PDF, TIFF, kind of whatever. GalenETL can provide a custom naming convention for each exported file if that's necessary. We've done migrations with customers where they wanted each note and scan to be exported to a PDF and each file name to contain the patient's MRN, document type, and clinical date. And this makes it easier, this will make it easier for the user who's viewing the files to know what file they're looking at. With that naming convention, though, you might have picked up on a logical error with that. What happens if a patient has two of the same type of document with the same date? That would technically try to create two of the same files with the same name. And since you can't have two files with the same name, we normally add a unique identifier to the end of the file name just for this purpose when we do things like this. It won't really affect the readability of that document name, but it just ensures we won't run into issues with trying to create two files with the same name. We've also worked with many customers to export the document and image files and in an index file in a format that can then be imported into their DMS, or document management system. These document management systems usually integrate with an EHR, so this is a really popular way to migrate these types of data. As I mentioned before, we've created plugins to deal with image compression issues. We've also created plugins to deal with encryption issues placed upon some of the documents and images by the systems that they reside in. The plugins in this way decrypt the documents to get into a more traditional format like RTF or HTML, whatever it may be, and then we can transform it into another format like PDF or TIFF. We've also run into proprietary file formats for things like scanned images in certain systems. Again, we've built plugins for GalenETL that can transform these proprietary file formats into something more workable like PDF. And we'll actually look at one of those such examples later. There are custom elements that can be added into certain file types when we export them to disk or into a target system. Data such as page numbers, headers, and footers can be applied to documents. Say a customer might want a footer on each file that contains the patient MRN, first name, and last name, so that anyone who's looking at that file, that image file or document, knows what patient it references because the data will be there at the bottom of each page. So there's many possibilities when it comes to outputting images and documents from GalenETL, and it sort of all depends on the needs of the customer and the specific project. Documents and images that we've been talking about are a very important part of any data migration, obviously, but they're really only two types of data out of many of the data types. What about the other clinical data? Well, one of the most commonly used products of GalenETL, especially during a data migration, is a continuity of care document, and that takes care of this. The continuity of care document, or a CCD, is an increasingly important method of migrating clinical data. GalenETL employs a CCD plugin that produces a single XML document per patient that contains all of the relevant clinical information for that patient. And then many times, this document can be then ingested into the target EHR through various means. The CCD that's generated from GalenETL conforms to healthcare IT standards, so it can be used to transmit data with a wide variety of EHRs that follow that standard. It uses many of the standard code sets that I touched on earlier, like IC9, IC10, RX norm, SNOMED. And the reason for this is so that the target systems can match up data elements to values in their own dictionaries based on these codes. So that means there's no manual mapping required. And this is a huge win for data elements like problems, medications, and allergies, which can be very time-consuming, sometimes nearly impossible to map. So if the source system contains those codes, we can put them in the CCD. The real benefit of all of this is that the CCD that's created from GalenETL is going to be consistent regardless of what system we're extracting the data from. This ties back to GalenETL's data model that I talked about earlier, because the CCD plugin pulls from the data model in the same way every single time. So as long as the data is extracted correctly, the CCD will function similarly every time. And since the CCD generator was built in-house, it's designed with a flexible architecture. Now, it still operates within the HL7 CDA standard. However, we have some control over that. For example, the data migration analyst can choose what data elements to include in the CCD. This is all done as part of the configuration of the CCD plugin, and when the job service is started, it knows, okay, only include the specified data elements. So let's pretend that the objective is to only include problems, medications, and allergies on a CCD when it's being generated, no immunizations. So GalenETL, because of the configuration of the plugin in GalenETL, we're still allowed to extract, or we're still able to extract immunizations and store them in GalenETL from the source system, but maybe those immunizations are being converted in a different way, such as via HL7 messages. In addition, we only need to map what is necessary for the project. While there are standard code sets that are used for the actual problems, medications, and allergies themselves, like the ones we talked about earlier, there's usually still a need to map the ancillary data elements manually, like allergy reactions, medication frequencies, a couple of those. And the reason is so that these items are presented discretely, just like the actual elements themselves, so that they're presented discretely to the end user once the CCD has been imported to the target system. Because the source data exists in GalenETL, at least the source data for when the CCD is generated, the mapping can be prioritized based on highest usage, and we'll be able to know what to expect when the CCD is imported. Conversely, if the CCD was being generated from the source system itself directly, we wouldn't have that type of insight. And then, depending on what the target system is, Epic is one target system that comes to mind. Once that CCD has been imported, the clinical items can be reconciled. And this is a manual process to reconcile that data to the patient's chart. However, using those code sets that we mentioned earlier, each individual med or allergy or problem, it's matched up to its corresponding entry in Epic based on those code sets. So that manual process is just the user having to add that item to the patient's chart with the click of a button. Because of all this, the CCD is one of the most powerful tools that we use for our data migration, also because of its uniformity, its consistent data, and its usage of standard code sets. It allows for a very efficient conversion of data, and GalenETL can provide CCDs that are tailor-made to fit each project. Another major output of GalenETL are HL7 messages. I'm sure most of you are familiar with what HL7 messages are, so I won't go into too much detail, but they're one of the major ways data is converted during a migration. GalenETL has plugins that will generate any version of HL7 message. To support a data migration, there are often several different message types that are included, each to serve a different data set. So you've got MDM messages to convert notes and transcriptions, ORU messages to convert lab and radiology results, ADT messages to convert visit and encounter data, and so on. And GalenETL has plugins to create all of these different types of messages. One major benefit to the HL7 messages that GalenETL creates is that they're fully formatted. By this, I mean that there's no need to send the messages through an interface engine to perform any type of further data scrubbing. All of the translations and mappings are done on generation of the messages. So when GalenETL creates the messages, they already have the target system values in them. Now, many customers still send the messages through an engine, simply just to route them via TCP/IP, but the engine just acts as a pass-through in that case. It's not actually doing anything to the messages. Just like with the CCDs, HL7 messages are consistent no matter where the source data is coming from. The HL7 specification that GalenETL uses pulls from the data model in the same way every time, just like the CCD. The only thing that might change from one system to the next is what data is available to place in the messages. For example, some systems might contain more metadata about a result than other systems. And we can customize the messages in many ways, from choosing how many messages are included in each flat file output to which fields are actually populated within the messages. And we understand that there's sometimes different ways to utilize a given HL7 message type, so our specification is flexible to allow for the needs of the customer in the project. Furthermore, if we're not set up today to populate a certain field in a message, that doesn't mean we won't be tomorrow. We can and we do add functionality to the plugins on a regular basis. To make things even better, GalenETL has excellent throughput when creating HL7 messages, at over 100, sometimes multiple hundreds per second. This allows for quick and efficient message generation, which is a huge help during a large migration with millions of records of data sometimes. And GalenETL can also include image data in HL7 messages as base64 encoded content within the message. If the target system or environment can decode this base64 content and then save that image file to a secure location, we've used this method to migrate millions of image files for a conversion in the past. It's just one more helpful feature when it comes to migrating scanned images specifically. And all in all, GalenETL is a fantastic tool to use for providing HL7 messages for data migration. The final GalenETL output that I'll be talking about today is also one of the most impressive in my opinion. GalenETL, or Galen, has created what we call a chart summary. The chart summary is a PDF that contains all of the clinical data for a patient. So it's a single document that essentially reads like their chart. And now it's not a legal medical record or anything like that, but it does give a clear, concise snapshot of a patient's data at a given time. There's a separate section for those data elements. So we have a separate section for allergies, separate section for medications, results, problems, etc. And the goal of the chart summary is to be a representation of how the data exists and how it reads in a source system. GalenETL is essentially just rendering the data that's been extracted. And so the effect of this is that there's very minimal mapping required because all of the data that's being displayed is non-discrete on that PDF. Really, the only mapping that's required for a chart summary is to support the actual migration of the chart summary PDF itself. It's typically imported as a scanned image since the PDF, so it will need to be mapped like a normal scanned image. And on that related point of scanned images and notes, the chart summary doesn't contain the notes and the scanned images for a patient. I mean, as you can imagine, if you did that, you'd have a really, really long, large PDF. And that would sort of defeat the purpose of the chart summary, which is to provide quick access and concise summary of a patient's medical record. So in a chart summary conversion, the notes and the scanned images are migrated separately just as if they would be for any other migration. The chart summary is also very customizable in the way that it can be configured to look. The chart, it can contain a cover page with or without a table of contents. The customer can choose the name of the document if they want to name it something different than chart summary. They can include their own logo on the chart summary. There can be headers and footers that are added, much like we talked about earlier, and then page numbers that can be added. The ordering of each item within a section can be chosen. Some customers wish to order certain sections by date, like results, for instance. Other sections not. Maybe they want to order other sections by name, alphabetical. The order of the sections themselves can be specified. Maybe allergies should be first, or maybe results should be first. The order can be configured. And then I may sound like a broken record here, but another benefit of the chart summaries is that they're consistent. The only thing that changes is the data that's in them, regardless of the source, so they're the same every time. So as you can see, there's a plethora of options when it comes to designing how the chart summary is going to look for your organization. And because of this, we feel that the chart summary is a powerful tool that can be used when it comes to choosing how to migrate your data. And here's a screenshot of what a chart summary might look like. And it's only a couple sections. It's obviously difficult to show the entire chart summary since this can be multiple pages. But this shows the allergies and the problems or part of the problem section for a given chart summary. How complete some of the sections look depends on what data is available. So you see some openness in some of those headers. So it just depends on what data is available in the legacy system that can populate the chart summary. But this just gives an indication of what you might expect from a chart summary migration. So I've been talking a lot about custom plugins so far in the presentation and different types of plugins. We've got custom plugins that can transform TIFFs, custom plugins that can export PDFs, but there's another set of custom plugins that are very specific in the work that they do, and we're going to talk a little bit about those. So there are plugins that have been built for GalenETL to accomplish a single goal, which is to get data out of or format data for import into different systems. And here's an image again, the image that you saw earlier in the presentation, but I think it effectively outlines some of the many vendors that we've worked with and also some of the many systems that we've built custom plugins for. Obviously, this isn't an exhaustive list, and that list is growing constantly. So let's look a little bit more into what some of the custom plugins are that we have. So on this first slide, there's a reason that I listed these three systems first, because they're three of the biggest players in the industry, and we've worked with customers to import data into all three of these EHRs. So GalenETL has specific plugins to work with each system, formatting the data that exists in the GalenETL database to the required specification of each system. To start off for Cerner, GalenETL can create the import files that are required, one per data type, that are needed to import the data to Cerner. The typical data sets are available, problems, meds, allergies, results, etc. And each import file pulls from the GalenETL data model. These import files contain discrete data where every allergy, every lab result, every medication is its own record in the file. So it allows for discrete data conversion, which overall is probably the preferred approach most of the time in a data migration. For a migration to Meditech, we've done things a little bit differently. GalenETL creates PDF files from the data that's been extracted. These PDFs are exported to disk, and then an associated index file is created per the Meditech specification. So these PDFs that are then imported to Meditech as documents. In this way, we'll convert notes, PDF, scanned images as PDF, and then to migrate the rest of the clinical data, we'll use a chart summary PDF for each patient. So this chart summary provides all of the data for that patient in a single document that can then be imported to Meditech. The method for migrating data to Epic is a little bit different than even both of those two others. And I mentioned GalenETL's HL7 exporter plugins, and we use sort of a version of those for importing data to Epic bridges. The data migration interfaces in bridges follow the HL7 specification, obviously, so we leverage our existing HL7 plugins, but we really tweak them with a few things that are specific to migrations. And as per the HL7 specification, we've got different message types, different plugins to work with all of the major data elements. And one thing that's not on this slide specifically is mention of CCDs. So I've talked about CCDs a little bit about and importing them. They can be imported into a target system. And GalenETL can create CCDs that can be then imported into the system depending on how that system accepts CCDs. And that's true for these specific systems as well. So when we do a migration or we're working on a migration to any of these three systems, we often include a CCD conversion as part of the overall migration project to cover those data elements like problems and medications and allergies, immunizations, things like that. Greenway Prime Suite is another EHR that we have a custom plugin for. Greenway requires its own set of custom plugins for the extraction of documents, so scanned images and notes. Greenway notes are stored in a compressed binary format, which is that GMT, the Greenway Medication Technologies format, which really, it just contains underlying XML. XML data, if for anyone that's not familiar with it, is wrapped in tags like HTML, but the tags in XML are not predefined. So they can really mean kind of whatever the person who created the XML wants them to mean. And that's where the specific associated style sheet comes in. The style sheet is the code to unlocking what the tags are really actually supposed to mean. And the style sheet specifies the formatting for the content that's contained in XML. We were able to integrate Greenway style sheets into our plugin to render the notes that are based on the XML binary. The scanned images, which are also stored as compressed binary, are really TIFF files, but they also have some issues with them. The TIFF images are stored as compressed binary, like I mentioned, and normally there's a standardized format for these. There's a start and a header tag, followed by an image data, and then a closing and a footer tag. But in the Greenway environment, we found that this wasn't always the case for those TIFFs. Some TIFFs would have a start tag, followed immediately by an end tag. So we implemented checks in our plugin to handle these situations. The PDFs, again, stored as compressed binary. But once we've kind of peeled back that layer and they're extracted, they're more or less standard PDFs that we can use like any other PDFs that we create. And then for eClinicalWorks. eClinicalWorks stores its progress notes as an encrypted XML string. GalenETL has a plugin that will decrypt the XML. However, like I mentioned for Greenway, XML all by itself isn't all that useful. It contains the content of the note, but none of the formatting. So then the plugin, just like for Greenway, applies the appropriate style sheet, and then it can output that XML or HTML to PDF and then to HTML, or simply just save the resulting XML. Both Greenway and eClinicalWorks, what we were just talking about, they use relatively common file formats like XML and PDF and TIFF, but the way that they store their data is not straightforward. So it makes it difficult to get it out. So that's the reason for the plugins, and that's really where GalenETL is able to provide its value with these types of systems. EMDs has a unique scenario where it stores lab results in QL7 format, which is similar to HL7. This QL7 can either be referenced in a flat file or it can be referenced at a URL address. GalenETL will read in the text from whichever one of these sources is being used, and then it will parse that data. At that point, when it has the parsed data, the text mirrors HL7 format, so we can reference that HL7 standard to identify each data field. And then GalenETL comes full circle because it creates a result-specific PDF chart summary, complete with options like cover page and custom text, just like the full chart summary plugin. But this chart summary only contains the QL7 lab results. And then this PDF can be imported into the target system, just like how the rest of the scanned images are being handled. Then we've got CPSI. CPSI takes a totally unique and complex storage approach, or totally unique and complex approach to the storage of data in that system. I've personally worked on a CPSI data migration, and I can definitely attest to that. For starters, the scanned images are stored in a completely proprietary format. They're stored as physical files at least, which is a good thing, and GalenETL is able to transform these image files into PDFs, which then can be used however a normal PDF would be used. And in fact, much of the clinical data within CPSI is file-based, is stored in files. So the notes and the results are also two items that are stored in text files on disk. But to get at these files, there's multiple layers of compression to get through. Think of a zip file that contains another zip file that contains another zip file. The GalenETL plugin can go into these layers of compression and peel them back to get to the actual plain text file that contains the data being looked for. To make matters more interesting, this text file might contain all of the notes and results for a given hospital visit, so not just the one you're looking for. And the trick is to extract only the specific note or result or whatever you're actually looking for. But the plugin handles all of that. A third complication with the data from CPSI is that, and this applies to the notes and the results, is that the CPSI actually stores sort of two types of data, archived and active data. And after a certain amount of time, active data becomes archived, and the storage locations actually change for that archived data. But the plugin is smart enough to handle these types of situations, and it knows where to look for the data, regardless of whether you need to go get an active note or an archived note. So as you can see with these different types of systems, there's types of custom functionality that GalenETL provides. It's really good at getting data out of and putting data into different systems. Now I'll touch briefly on the different GalenETL plugins available for use specifically with Allscripts TouchWorks EHR. We've got a number of them. TouchWorks is one of the systems that we frequently load data into, so some of the plugins that we have built for support that. There is a scanned image loader, start off, which I'm sure, as you guessed it, loads scanned images into TouchWorks. It utilizes the same functionality that's called when a user manually scans a document in on a daily basis. Typically, we'll either load TIFF or PDF documents with that plugin, and if the source images are in a different format, GalenETL will simply convert them prior to loading to TouchWorks. Then we have the scanned image extractor, which is also pretty self-explanatory. It extracts the scanned images that exist in TouchWorks and preps them for whatever the next step may be. On those scanned images, we've got digital annotations of signatures that can be added to the scanned images. And when we extract them, they're rendered or they're burned on top of the image, because when they're actually residing in the source system in TouchWorks, those annotations don't actually exist on the image themselves. They're rendered when the user clicks it and brings the image up. So we need to burn them onto the top of the image. So this plugin, the annotation plugin, will search for any annotations and it will put them onto the image during the extraction process. Then we also have a plugin to extract forms from TouchWorks for those customers who use forms. There are a series of discrete data loaders for any data migration that involves loading discrete data into TouchWorks. The benefit of this method is that any items that are sent in discretely will display in TouchWorks as if they were manually added by a user, so they can be reported off of, interacted with, and updated just like any other item. There's also a specific plugin for loading chart summaries into TouchWorks. It operates similarly to the scanned image loader, since it's loading a PDF, but it has some specific settings specific to chart summaries that set it apart. And then sitting on top of all of the loader plugins is the patient matching plugin. As I'm sure everyone's aware, data integrity is paramount within the healthcare IT industry, so we always want to make sure that we're matching to the correct patient before loading data to that patient's chart. The patient matching plugin executes a series of algorithms that are designed to ensure a high percentage match to a patient in TouchWorks. And there are also some options to configure the specific patient matching logic that fits best for a specific project depending on the legacy data that we have. But really the goal of that patient matching plugin is to ensure that the correct patient is found. And that wraps up a look at some vendor-specific functionality that exists within GalenETL for plugins. What we've just talked about is not a full list of the custom plugins that we've built, and we are actually adding more all the time too. The next topic that we'll discuss is extractors and parsers, which are both components of GalenETL that are used to aid in the extraction of data from outside systems. We've been talking a lot during the presentation about extracting data from legacy systems, and for the most part, the methodology and the origin of these extracts is a SQL query that's pulling data from a database. One way to assist with this SQL query, this extract, is to use a GalenETL plugin called an extractor. The extractor's sole purpose is to pull data from an external system. The most common type of extractor that we use is the generic SQL extractor, which takes in a SQL query and can run it against an external database over and over. The nice part about using the extractor versus simply running the query on your own is that it can be set up to run at specific times. And this provides more freedom to those performing the extracts, and it allows the extracts to be run at times when someone may not wish to have to manually kick the extract off, like say the middle of the night. Each execution of the extractor is designed to be for a single data type, i.e. the extractor will be run with an extract query for problems, and then separately the extractor will be run with an extract query for medications. And this just allows for more flexibility with updating any of the extracts as a result of testing and validation and the issues that might come up. Using an extractor like the generic SQL extractor provides consistency for the duration of the project, because once the extractor is set up, it's going to run the same no matter how many times it's run. And this cuts down on errors and the need for manual intervention with those extracts. And a parser accomplishes the same task as an extractor, but in a slightly different way. So because of this, a parser can really be classified as a type of extractor. A parser is used to extract data from an outside source that's not a database. Most of the time, this is going to be some type of data file in a format that's consistent and has a specification. And lo and behold, the two of the most common parsers that we use are exactly that. First off, the HL7 parser can read from a set of HL7 messages and pull the required data out as individual fields. It then saves the data to the GalenETL database where it can be acted upon in whatever way necessary. Maybe the objective is to create a chart summary from HL7 messages that have been sent from an upstream system. And the parser supports all versions of HL7 as well. And the second parser that's used most frequently is a CCD parser. This plugin reads in a CCD in XML format and again uses the industry standards to gather the discrete elements and save them to the GalenETL database. Assuming the CCD meets the aforementioned standards, the plugin can locate the standard code sets we've been talking about, like IC9, IC10, RxNorm, and it can save those to the database as well. Unlike the generic SQL extractor, and to a certain extent the HL7 parser, the CCD parser handles all data types at once. Since a single CCD XML file can contain multiple data types, when parsing through that document, the plugin takes data from each section and saves it to its corresponding location in the GalenETL data model. Once that data is in the database, it's just like any other data migration. We've even worked on a project where we parsed a set of CCDs, so that data got saved to GalenETL, then we scrubbed the data once it was in GalenETL by applying mappings and discarding certain data. And then we used our own CCD generator plugin to create brand new CCDs that were to be imported into the target system. And this may seem a little bit counterproductive, but it's actually pretty common for data migrations because the data that's extracted from the source system is often nowhere near ready to be imported into the target system. There's a lot of manipulation and scrubbing that needs to happen first, and GalenETL allows us to do that by storing that data in the GalenETL database. Next, we're going to talk about managing customizations with GalenETL. We've talked about custom plugins, but the customizations that I mean in this sense are a little bit different. We wouldn't ever pretend that every data migration project is the same and that the plugins as the plugins exist now, that they're going to be sufficient for every project in the future. Sometimes with systems that we haven't extracted data from before, or due to upgrades in known systems that we have extracted data from before, we encounter issues where there's a scenario we aren't prepared to handle. Maybe there's a new image compression type we haven't seen yet. And in these situations, there's usually going to have to be a change to an existing GalenETL plugin. Other times, a customer requests a specific piece of functionality that doesn't currently exist in the plugin that's being used. Maybe there is an addition to the chart summary that the customer would like. These different types of customizations are inevitable in data migrations, and GalenETL is set up to handle them with ease. GalenETL's plugin architecture that I've been talking about, it allows us to make safe customizations to plugins in the middle of a data migration project. So a customization that's made to a plugin, it only affects the task that that specific plugin is performing. It doesn't affect any other plugins in sequence. Since tasks are processed linearly, for every objective that GalenETL accomplishes, there's often multiple plugins linked together to meet that goal. There's rarely ever a single plugin that's used on its own. So in a string of 3 plugins being used to accomplish some goal, if the middle one is changed, it won't affect the other 2. And one reason for this is that plugins are separate project files from the GalenETL job service, so they're not dependent on the GalenETL installation itself. When a plugin is updated, it can just be dropped into the client's environment without requiring any changes or reconfiguration or reinstallation of GalenETL. And this is important because, like any piece of software, GalenETL has version numbers, different versions, and being able to deploy a plugin, say an updated plugin, to a client's environment after a customization, and not have to worry about being on the right version of GalenETL, it ensures there won't be any delays in the project. And customizations also don't require regression testing, since the scope of the change to a plugin is so narrow amongst the entire objective being performed by a set of plugins. So now let's look at an example of how a customization might fit into a data migration project. In this example, the original scope of the project is to load TIFF documents into a certain EHR. Like I mentioned earlier, with most tasks, there are multiple plugins strung together, since each one has its own function. A few weeks into the project, it's discovered that the legacy system contains HTML files as well as TIFF files. Now plugin B needs to be modified to accommodate the HTML documents. Once plugin B is modified, it's dropped into the mix, but plugin A and plugin C haven't changed at all. They're still working just as they did before. Then, a few weeks later, the customer requests to add page numbers and patient demographics, maybe a header or footer or something, onto the PDFs. This customization is a little different in that it requires a brand new plugin. And the reason for that is that the goal of each plugin is to accomplish a task, but it also shouldn't do anything more than it needs to. If we were to add the overlaying of page numbers and headers and footers to plugin B, it would work fine. But then what happens when a project comes along where we need to convert JPEGs to PDF instead of TIFF and overlay those same headers, footers, and page numbers? Now we would have had to build a whole new plugin to handle JPEGs, and we end up with duplicate code and functionality that does the same thing. So not only is creating a new plugin a good practice, but now we've gained an efficiency for any project in the future that has these same requirements. So plugin D, the new plugin, is thrown into the mix and our itinerary grows by 1. Again, each plugin is handling its own business and the project can move along. Now this may seem like an oversimplified example, but situations like this do happen all the time on a data migration project. Now we're going to talk a little bit about auditing with GalenETL. Anytime that we're interacting with loading healthcare data, especially to a production system, it's imperative that there be a record of what was done when. And GalenETL is no different. GalenETL has full auditing capabilities that are recorded and stored in the GalenETL database. Every time a document is transformed, a patient matched, an index file updated, a CCD generated, there's a record of it. And furthermore, it ties back to the patient and to the direct item if it's applicable. Auditing within GalenETL helps answer fundamental questions that inevitably arise during the project. Questions like, what data was loaded or what data was exported for this specific patient? Or how long will data take to load or export for all patients? With some standard reports, we can answer these questions and provide data on what, when, and how actions happen. The second question actually that I just mentioned is an important one because not only do we want auditing data in case there's questions about what was done, but auditing can also assist the project team by providing information that can be used to plan the go live or budget time for certain milestones. So you know how long, like say the load or the export of data is going to take. Another reason to collect audit data is to track errors. It's one thing to have a record of everything that's been loaded or exported successfully, but GalenETL also provides information for data that wasn't loaded or exported successfully. If an item errors, there's an error message returned that provides guidance on how to resolve the error message. For those errors that can't be resolved by the technical resource directly, there are reports that can be generated for the benefit of the entire project team on those errors. So overall, GalenETL maintains a comprehensive auditing mechanism that can assist both project resources and external stakeholders. And then the last topic I want to cover today before we get to our GalenETL demo is, surprise, surprise, another plugin. This plugin is a little bit different though. It was created to support one of the major phases of data migration, which is testing and validation. During this phase of the migration project, Galen resources work with customer resources to validate the data that's been loaded. This often involves bringing up both legacy and target systems and comparing the data between them. The Validation Script Generator plugin creates Microsoft Excel workbooks that aid in this effort. Typically, there's one workbook per patient, and the tester is provided all of the data points they're supposed to test for each data element for that patient, including the name of the item, the clinical date, and then any ancillary metadata about the item. These workbooks allow users to quickly review the data that's being migrated and check off whether it meets the criteria in the target system. The testers can simply check off whether an item passes or it fails. And this allows for the Galen project team resources to easily migrate any reported issues, any failures, to our internal migrations issue tracker that we use to keep track of all of the issues. So this tracker provides quick access to the issues for a project and also provides updates on where each issue stands. And previously, the creation of these validation workbooks was a manual process, a manual effort that could sometimes take many hours. But since we've integrated it into GalenETL, it allows those project resources to focus more on testing and validation and identifying issues, which leads to a more successful migration. Okay, so now I'm going to do a brief demonstration of some of the functionality of GalenETL. So here's a screenshot of the GalenETL job service. I'll be performing 4 different tasks that are common to data migrations: converting a TIFF image to PDF, converting an RTF document to PDF, generating a CCD, and generating an HL7 message. So let's jump over to my desktop where I have GalenETL installed and these items queued up. So most of the interaction, or almost all of the interaction that we do with GalenETL is done via SQL Server. So right now I'm using SQL Server Management Studio to kick off these jobs. The first thing that I'm going to do is start GalenETL. And it's just like any other program. There's an exe that you can use to run GalenETL. And you can see this this job service here, this applet. This is the screenshot that we just saw in the presentation. So the first job, the first task that we want to accomplish is to convert a TIFF to a PDF. Now I have the TIFF sitting on disk here. I'll go ahead and bring it open, double click on it. See, it's a scanned image. It's a TIFF. Looks like it's a patient health questionnaire. So this is going to be converted to PDF. So I'll go back to Management Studio. I'm going to start the job. And I'll bring up GalenETL. And we can see that job 4, which is the job I just started, is running. And the item was processing. Now it's been processed. And it processed successfully since it went to the processed category there. So if we go back to our files, and there's a folder for outputs, and in this documents folder, here is the PDF. And you can see I kind of took the same methodology that I was talking about earlier, where it's using the file name is the patient MRN, patient first name, last name, and then the name of the document. So if I double click on that, it opens the PDF, and you can see it looks exactly the same as the TIFF did. The next thing that we'll be doing is converting an RTF to PDF. Now, this is going to be an RTF note, and it's not contained as a separate file on disk. It's actually stored in a database, but I went and copied it out to a physical file so we could look at it. So here's the RTF note as it exists in the database. Now, it's not terribly easy to read. RTF itself is not all that easy to read, but we're going to convert it to PDF to make it much more viewable. So I'll go ahead and start the second job. It's job 5, and once again, open GalenETL. Now we can see that job 4 and 5 is running, and now we have 2 processed items. So that RTF to PDF processed successfully. So I'll go back to our outputs, and we can see we've got another document in this output. Again, patient MRN, first name, last name, and then it's a visit note. So I'll double click on that, pull open the PDF, zoom out a little bit, and you can see here's the note for that patient. Obviously, much more easily readable in PDF format than RTF. Okay, so then the third job that we'll be running is generating a CCD. Now, the data for a CCD is not stored as a file. It's not stored in a single field or column in a database. It's stored in all of the tables in the GalenETL data model that contain the allergies, the problems, the medications for that patient. And so the plugin will take all of the data from those tables, put it together, and create the CCD. So I'll go ahead and start that job. Go back to GalenETL again. Now job 6 is running, and we've got another item processed. So I'll go back to our outputs, go back one directory to the CCD folder. I'll go ahead and open that up. And now, somewhat like the RTF, the CCD is XML. So in and of itself, it's not the most readable, but you can see that this is a care document for this patient, has a patient name and information there. And then we can start to see here's the section for allergies. Starts right there. And then there's a section for medications and problems, etc. So the real value of this is not necessarily reading the XML. It's more when the data gets into the target system and the data elements are able to be matched up to the discrete element in the target system, and the user can view the data there. Then the fourth and final job we're running is to create an HL7 message. Now this is going to be an MDM T02 message, which it just signifies a new document. So I'll go ahead and start that. And we can go to GalenETL. See, we have job 7 running now, and it processed successfully. And this is actually the same RTF note that we just converted to PDF, but now instead of converting it to PDF, we're putting it in an HL7 message. So I'll go back to our outputs. You can see here's the message here. I open it up. And for anyone that's familiar with viewing HL7 messages, you'll recognize this, but the RTF note content itself is stored in the body of the HL7 message. And then once this is sent in on the interface, the target system will read that RTF in and render it just like a normal note. All right. Well, that concludes a demonstration of GalenETL. Hopefully that gave you kind of a quick insight into how GalenETL is run, how we accomplish the types of tasks that we accomplish with GalenETL. Go back to the PowerPoint. So just wanted to say to close, I just want to close by saying that based on all the topics that we've kind of talked about today, it's pretty evident that GalenETL or Galen provides consistent data migration services that follow best practices, that promote safety, predictability, and efficiency. And GalenETL is really the key to making this all possible. So that does conclude the presentation portion of today's webcast. Thank you everyone for joining and listening, and now I'll turn it back over to Julie.
Thank you, August, for that compelling presentation. To wrap it up, before we get to any questions that people might have, let's look at why choose Galen. We have a lot of community support. I encourage you to visit our Knowledge Center on our website, where you can see our white papers on all of our solutions and read some of our success stories. We have a pretty big footprint in moving healthcare IT forward, and we are always looking to freely share our knowledge and our expertise. We've produced over 620 blog posts and over 200 webinars, just like this one, also available for your viewing on our YouTube channel. So we encourage you to visit our website, galenhealthcare.com, and experience the difference with Galen. The slides from this webcast will be available on our public wiki shortly after the conclusion of this presentation. There's also a link to our website on this page. I'm going to take a moment now to see if there are any questions and pass those back over to August.
Thanks, Julie. Yep, it looks like we've got time for a few questions. So I'll go ahead and see any questions that have been entered during the presentation. Okay, so here's one. Let's see. The question is, what sort of impact does GalenETL have on a client's environment, and what are the long-term plans for it once the data migration is complete? And that's a really good question, and one that we actually get asked quite a bit by clients, both during a migration and at the end of a migration. So in terms of GalenETL and kind of what impact or how it fits into a customer's environment, normally what we do is we have a customer spin up or create a conversion server for us, a separate environment that we use for the migration, someplace that we can install GalenETL and just have that has plenty of disk space that we can just work with, so we're not interfering with any normal activities that are going on. And we'll use that server for the duration of the project. And then once the project is over, usually we'll keep it around for a few months or so after the project is over, or after the go live rather, just so in case there's any cleanup activities or any questions about anything that we did. And then once a period of time has elapsed, the data that's on that server can be archived or put off that server. And then also the GalenETL database should be archived as well. We still want to keep around the database for, in case there's any questions down the road, a year in the future or something like that. But it doesn't need to be on the server or anything and taking up space on an environment. It can be uninstalled and everything like that. Okay, looks like there's another question. This question is, how long has GalenETL been around, and how long have we been developing it? Well, I guess to answer the second part of that question, how long have we been developing it? We're still developing it. It's constantly being developed, and it's constantly evolving. And honestly, during the presentation today, someone's probably adding some more functionality to GalenETL. It's been around since about 2012. That's when we started kind of developing that solution. We've been doing migrations for longer than that, but that's kind of when we formulated a plan for GalenETL, and it kind of really became our de facto solution for migrations. Let's see, another question here. It says, I remembered that you mentioned something about performance and throughput. And is GalenETL multi-threaded, or how do you achieve that throughput? And the answer is that GalenETL is multi-threaded, and that's what kind of helps us achieve that high throughput that we were talking about earlier with that was generating HL7 messages. By default, GalenETL is set up, I believe, to use a number of threads that's equal to 2 times the number of CPUs on the server. So that's just kind of its default state. But that's something that can be changed. The technical analyst or the migration analyst from Galen can go in there and change the number of threads that it's using. up or down to kind of achieve maximum throughput, depending on the specs of the server and what kind of might work better or best for that project. Let's see, another question here is GalenETL something that could be used by clients themselves? And at this point, it's not. It's something that we use with our resources on projects when clients contract with us. And the setup and the configuration and just kind of interacting with it, I mentioned that a lot of the interaction is done via SQL Server and SQL Server Management Studio. That's just not something that we are currently kind of set up to train outside resources on. So it's something that we have the internal knowledge to handle. But at this point, we're not opening that up to customers. But you never know in the future sometime, maybe in the future. Okay. Well, I think that's all the time we have for questions today. But if we didn't get to your question, we'll go ahead and we did get the question, but we'll go ahead and post the answer on our blog. So look for that. And we'll answer all the questions. But just wanted to say thanks, everyone, for joining today, and have a great rest of your day.